What is the value of? Okay, well, let's just do this manually. The first one is going to be, let's see here, that number with a little over a million. And the next one is 999,999. And then when you subtract those, you get 2. So the answer is 8. A model used to estimate the time it will take to hike to the top of the mountain on a trail is of the form t is equal to AL plus BG, where A and B are constants. T is the time in minutes, and L is the length of the trail in miles, and G is the altitude gain in feet. The model estimates that it will take 69 minutes to hike to the top of the trail if a trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1,100 feet. How many minutes does the model estimate it will take to hike to the top if the trail is 4.2 miles long and ascends 4,000 feet? All right, so we have to basically convert the words of the question, the sentences, into math. Okay, no problem. The first part of it, I believe, would be 69 is equal to A times 1.5 plus B times 800. Just basically, I think it's this sentence right here, that one. And then the next sentence would be 69 is equal to A times 1.2 plus B times 1100. And that is this sentence right here. Okay, so we got two equations, two variables, so we should be able to solve this. And I guess at the end we would be able to figure out this one, which would be T is equal to A times 4.2 plus B times 4,000. So obviously we're going to need to figure out what is A and B. Okay, no problem. So here we go. I'll do 4 times equation 1 minus 5 times equation 2. And that will give me 276 minus 345. That will give me, let me think about this, 6A plus 3200B minus 6A minus 5500B. Yeah. And then that would mean minus 69 is equal to the intentionally doing this to ensure that one of those variables cancels. And that's minus, hold on here. What did I do? Sorry, there's one more zero. Good thing I caught that. 2300B, and then B becomes 0.03. Okay, and then when you sub this back into any one of these and solve for A, you'll get A is equal to 30. So coming back, let's just keep this all on the same screen. It would be 30 times 4.2 plus 0.03 times 4,000. And when you crunch out those numbers, you will get 246. And that would be choice B. What is the sum of the digits of the smallest prime that can be written as the sum of 5 distinct primes? Let's list the prime numbers. Let's just list a few of them. I really don't know how long we have to experiment here, but let's try. So there's obviously 1, 2, 3, 4, 5 prime numbers that when we add them up, they equal a prime number. Okay. So I guess let me experiment here, and actually I think it probably helps if I list a few more prime numbers. It'll help me out a little bit. So after 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, and so on. I hope that let's just concentrate on these and see if we can get an answer, and if I can't, then I'll list more. Okay, so we want this kind of scenario here. 5 of these prime numbers that when added equal another prime number. All right. Okay, so with a little bit of experimentation, I choose 3 and 5, 7, 11, and 17. And that would total 43. And let's see, 3, 5, 7, 11, and 17. Those are indeed prime, and so is 43. So I've achieved what the question wants, but then what they want is the sum of digits of that smallest prime. So they want the sum of the digits of 43. Well, that would be 4 plus 3, and that is 7. So 7 is the answer, and that would be choice B. The number 2024 is written as the sum of not necessarily distinct two-digit numbers. What is the least number of two-digit numbers needed to write the sum? The least number. Okay. The least number. So, two-digit numbers range from 10 to 99, right? So if we want 2024 to be the sum of a bunch of two-digit numbers, all the way, then we want the numbers to be as big as possible, because that way we would have the least number of two-digit numbers, and the biggest number is 99 of this range. So a whole bunch of 99s, and then eventually probably something left over. So I think if you do 20 of these 99s, you would get sufficiently close to 2024. 20 times 99 is what? 1980. So, and then we have to add another number, so I'd have to add 44, correct? Yeah. So how many numbers? I used 20 of the 99s, and I used just one 44. So I had 20 of the 99s plus 144, so I used 21 numbers. And that is basically the answer to the question. What is the least value of n such that n factorial is a multiple of 2024? So n factorial is 2024 times some k. It's a multiple, right? So the first thing I think that will be helpful is to convert this 2024 into its prime factorization. So I believe it's 2 times 2 times 2 times 11 times 23. And then we get that k. So that's n factorial. So we have to figure out the smallest value of n. Well, the smallest value of n would have to have at least these guys in it. Correct? Yeah. The smallest value of n factorial is what I should say. Okay, well, let's see. How about 23 factorial? It would have the 23 times 22, right? And then eventually you'll get to an 11. And then eventually you'll get to an 8. So that 23 is covered, that 11 is covered, and this 2 times 2 times 2 is 8, that would be covered. So I think that, and the k, we can just make it 1, because that, I mean up here, hold on, this k, we can just make that 1. We don't need, because it just says a multiple of 2024, right? It doesn't necessarily say that it has to be 2024 times 2 or times 3. So if k is 1, that's sufficient. So I think 23 factorial, yeah. So that would be D. What is the minimum number of successive swaps of adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A? All right. So we need 5 swaps to basically bring, you're starting with this guy, right? A, B, C, D, E, F. So to bring the A all the way to the end, we need 5 swaps, right? The first swap is here, then the next swap is there, then the next swap there, then the next swap there, then the next swap there. So 1, 2, 3, 4, 5. 5 swaps. Then you need 4 swaps to bring the B to the second end. So it'd be C, D, E, F. Yeah. Again, the 1 swap here, 2 swaps there, 3, the third swap, the 4th swap, and eventually B would be in that second last position. And then 3 swaps to get the C to the third last position, which would make this D, E, F, C, B, A, like that, right? C was switched there, then C was switched there, then C was switched there. and that would bring it there for its 3 swaps. And then 2 swaps to get the D inward a bit. And then finally 1 swap to exchange that E with the swap the E with the F. And like that. And I believe that is what we want, right? That's what we want. FEDCBA, FEDCBA. Okay, we got it. So then we have to add up all the swaps. And when you do, I believe that is a total of 15 swaps. So that would be D. The product of 3 integers is 60. What is the least possible positive sum of the 3 integers? Okay, so we have 3 integers. Let's call them A, B, and C, and their product is 60. Now 60 itself is 2 times 2 times 3 times 5. So let's experiment with this. Let's say the numbers are 4, 3, and 5. That means the sum of these would be 4 plus 3 plus 5. And that, of course, is 12. And 12 is actually not one of the answers, interestingly. Okay, let's experiment again. Let's try 2, 6, and 5. Right? If you get this is 2, this 2 times 3 is 6, and then that 5. That the product would, of course, be 60. And the sum would be 2 plus 6 plus 5. And that is 13. 13 is one of the answers. But they want the least. So I have to figure out, could I get any of those? I got this, but there's 4 answer choices that are smaller. And I think that could be achieved if some of these numbers are negative. Meaning, it doesn't actually say that the 3 integers have to be positive. These integers could be positive or negative, right? Because it doesn't specifically say they have to be positive. It does say that the sum has to be positive. Okay, so let's experiment with some negative numbers. Let me think about this for a second. What negative numbers? How about, let me write this out again. It's 2 times 2 times 3 times 5, right? But it could be, let's say 2 times 5. Then it could be 2 times 2 times 3. And then we could add just a 1. And that way, I'm pretty sure we could get something smaller. So this is like 10 and 6 and 1, right? But if 2 of these are negative, like for example, if it was negative 6 and negative 1, we would still get a product of 60. So this would still be valid. And therefore our numbers actually are 10, negative 6, and negative 1. And when you add these, you actually get 3. And 3 is actually the smallest positive sum that you can get with this type of experimentation. Amy, Bomani, Charlie, and Daria work in a chocolate factory. On Monday, Amy, Bomani, and Charlie started working at 1 p.m. and were able to pack 4, 3, and 3 packages, respectively. Every 3 minutes, at some time later, Daria joined the group, and Daria was able to pack 5 packages every 4 minutes. Together, they finished packing 450 packages at exactly 2:45 p.m. At what time did Daria join the group? So I have A, B, C, and D. These are representing the 4 people. And then on Monday, they're all gonna start at 1 p.m., right? Well, at least the first 3. Okay, and then every 3 minutes, so Q 3 minutes, they let's see here, packages are 4, 3, and 3. Okay. And then this time, we don't know. I think that's actually what we're trying to figure out. And this is every 4 minutes. Every 4 minutes, 5 packages. So there's a little bit of a difference between the first 3 and the 4th person. And by the time we get to 2:45, there's a total of 450 packages right there. Okay. So we got to come up with a math formula here. How does this actually happen? So how do we actually get to 450? Well, we go from 1 to 245, so that is 60 plus 40, 105 minutes, right? So 105 minutes. Now 105 divided by 3. Yeah. So 105 divided by 3, that's how many intervals, because it's every 3 minutes. And for each interval, it would be 4 packages for A. And then similarly, well, 105 over 3 is 35, so let me just put that in. Be 3 packages for B, and then 3 packages for C. And then for D, okay, I don't know the D. Okay, but very similarly, this was 105 over 3, so very similarly for D, we would put the time in minutes divided by 4. Yeah, so I don't know the time, so put T over 4, and then multiply by the fact that every one of those intervals gives 5 packages. So I'm pretty sure that's the math. So let's do this. This is 140 plus 105 plus 105 plus 5t over 4 is 450. All right. So 5t over 4, when we calculate this, would be 100. And then t, when you crunch out this, is 80. Now that means 80 minutes after D started, we got to 245. So subtract 80 minutes from 245. So it'd be 145 minus 20 minutes. So 125, I believe. Yeah. And therefore that would be choice A. In how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people so that each team has 2 juniors and 2 seniors? Okay, so what do we have here? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then we have 6 juniors and 6 seniors. Okay, let's talk about this. So this is group 1. This is group 2, and this is group 3. Well, I should have called them teams. No, you guys understand. Group, team, same thing, right? Okay, so let's talk about this. From the for group 1, we have to choose, from the 6 juniors, we have to choose 2. And then from the 6 seniors, we have to choose 2. And now, there's only 4 juniors left, so from those 4, you choose 2. And then there's only 4 seniors left. From those 4, you choose 2. Now there's only 2 juniors left. From those 2, you choose 2. And then from the 2 seniors left, you choose 2. So I'm pretty sure that's the math. So 6 choose 2 is 15. 4 choose 2 is 6. And then 2 choose 2 is just 1. So this is 8100. Okay, and that is one of the answer choices. But here's the thing. We've overcounted. The reason we've overcounted is because this has permutations. So G1, G2, G3 has 6 permutations. It could be done in different orders. It could be G1, G3, G2, and so on, right? G2 could come first. G1, G3, G2, G3, G1, G3, G1, G2, and then one more, right? What's the G3, G2, G1? So 1, 2, 3, 4, 5, 6. Yeah. So the 6 permutations, and they're all the same. So you have to take that 8100 and divide it by that 6 because you've overcounted by a factor of 6. And when you do, you get 1350. And that is actually the correct answer. So that would be choice B. Consider the following operation. Given a positive integer n, if n is a multiple of 3, then you replace n by n over 3. If n is not a multiple of 3, then you replace n by n plus 10. For example, beginning with 4, the procedure gives 4 to 14 to 24 to 8, 18, 6, 2, 12, and so on. Suppose you start with 100. What value results when you perform the operation exactly 100 times? Okay, so let's do this. We start with 100. Is that a multiple of 3? No. So if it's not, we go from n to n plus 10. Correct? So that would go to 110. And then is that a multiple of 3? No. So we would, again, use that operation. So we go to 120. But 120 is a multiple of 3. So if it's a multiple of 3, it goes from n to n over 3. So we go from 120 to n over 3, which is 120 divided by 3, which is 40. You got it? And then I think that's not a multiple of 10, so that would go to 50. That's not a multiple of... Sorry, what I should have said is the multiple of 3. That's going to go to 60. 60 is a multiple of 3, so then we use the first operation, so that goes to 20. 20 goes to 30, and then 30 is a multiple of 3, so we're going to go to 10, because you had divide by 3, you got to go with that operation. Then 10 is not a multiple of 3, so we're going to go to 20. 20 is not a multiple of 3, we go to 30. 30 is a multiple of 3, so we go to 10. Okay, so this kind of repeats itself and kind of keeps on going. Okay, that's what I thought, that you have to get a pattern, because it would take a long time to do this 100 times. Okay, so let's figure out how many times we did it so far. So this is one operation to get to 110. Second, third, fourth, fifth, sixth, seventh. So we got to that 30 after 7 operations. And then you just repeat 3 operations many, many times. Yeah. And then we got to figure out what is the 100th time. Okay, so 100 minus 7 is 93, and is 93 divisible by 3? I think so. That's 31, right? Yeah. So that basically means that you're going to have a whole bunch of ones, and then you're going to eventually just get right back to this. So this is obviously the first, the second, and this is the 7th. This is the 8th, this is the 9th, this is the 10th operation. And eventually, after a whole bunch, you're going to get to the 98th operation, the 99th, and the 100th. Yeah, because 7 plus 31 times 3 is 100. Correct? Yeah, because 93 plus 7. Yeah, so the 100th operation would result in the number 30. So that means the answer is C.